Hi everybody. In this session, we will discuss about what is an algorithm, what are the criteria of an algorithm, how to devise, analyze, validate an algorithm, and how to write an algorithm. In the earlier days of our schooling, we came across the word algorithm in mathematics, and we learned the definition as algorithm is a step-by-step procedure to solve a problem. This word algorithm has taken a special significance even in computer science. In the computer science, algorithm refers to a method that is used for a solution of a problem. The algorithm is defined as a finite set of instructions that, if followed, accomplish a particular task. In addition, all the algorithms must satisfy the following criteria. The first criteria is input. Zero or more quantities are to be supplied as an input to an algorithm. The second criteria is output. Any algorithm must provide at least one output. The third one is definiteness. The definiteness says that each instruction in the algorithm must be clear and unambiguous. There should not exist any instruction which creates ambiguity in the algorithm. Example, if we consider the instruction add 6 or 7 to x, it leads to two forms of instruction, either 6 plus x or 7 plus x, which leads to ambiguity. Similarly, the another instruction, compute 5 by 0, gives infinite result. Hence, such instructions should not be used in the algorithm. The fourth criteria is finiteness. If we trace out the instructions of an algorithm, then for all the cases, the algorithm must terminate after finite number of steps. The time taken for an algorithm termination should be reasonably small. If we consider an algorithm to check whether the position in the chess game leads to winning or not, then all the possibilities right from the beginning of the game are to be calculated. For this problem, even the most modern computers take billions of years to take the decision. Hence, we should ensure that any of the algorithm should complete at a particular point. The first criteria is effectiveness. Every instruction must be very basic so that it can be carried out in principle by a person using only pencil and paper. Algorithms that are definite and effective are called as computational procedures. One important example of computational procedure is operating system of digital computer. The procedure is designed to control the execution of jobs in such a way that when no jobs are available, it does not terminate but continues in waiting state until a new job is entered. To achieve the criteria of definiteness, algorithms are written using programming languages. Such languages are designed so that each sentence has a unique meaning. A program is the expression of an algorithm in programming languages. We use the words procedure, function, and subroutine synonymously to indicate program. Now, let us see how to devise algorithms. Devising algorithms is an art. It may be never fully automated. There are various techniques to devise the algorithms. Few of them are divide and conquer, dynamic programming, linear programming, nonlinear programming, etc. We will come across these devised techniques in the further courses. The next question comes, how to validate an algorithm. Once an algorithm is devised, it is necessary to show that it computes the correct answer for all the possible inputs. This process is termed as algorithm validation. The algorithm need not be expressed as a program for the sake of validation. It is sufficient in this way to validate the algorithm. Let us see how to analyze the algorithm. As an algorithm is executed, it uses computer's CPU to perform operations and its memory to store the data and programs. Now, analysis of algorithms refers to the task of determining how much computing time and the space required for the algorithm. This analysis of algorithms are also known as performance analysis. It majorly deals with the calculations of time complexities and space complexity of the algorithms. When an algorithm is implemented as a program using programming language, then how can I test it? This testing can be done in two phases, debugging or profiling. Debugging is the process of executing programs on sample datasets. It determines whether the faulty results occur, and if so, we can correct them. The drawback of debugging is that it can point only the presence of errors, but not their absence. Profiling, also called as performance management, is the process of executing a correct program on different datasets and measuring the time and space it takes to compute the result. In this profiling, the correct program is given to 2 or more people to execute with the different data sets, and the results are computed and compared for the time and space. These timing figures are useful in that they may confirm the logical places to perform useful optimization. How can I express my algorithm? Yes, you can express algorithm in your own way. The first important way of expression is by using natural language like English. If we select this option, we must make sure that the instructions are clear, unambiguous, that is, they are definite. The other way of representation is graphical representation, which is nothing but a flowchart. They will work fine, but only for the simple and small algorithms. When the algorithm is large and complex, flowcharts are not suitable. The third technique of representing algorithm is pseudocode. Pseudocode convention is very similar to that of the programming language, which does not involve any syntax. It's better to represent an algorithm in pseudocode to avoid infinite. In this session, I use pseudocode notation to represent the algorithm. The convention used here is every algorithm is having 2 steps, heading and the body. The algorithm heading comprises of the keyword algorithm, name of the algorithm, and the parameter list to be supplied to the algorithm. The body of the algorithm comprises of the instructions encoded in the braces. An algorithm may or may not return a value. Now, let us write an algorithm to calculate sum of array elements. A is an array, N is the number of elements. We declare S as a variable initially with value of 0. For I is equal to 1 to iterate from the first element to the nth element in the array, read the particular element A of I and add to the S. Return the value of S. Let us see the second example, how to write an algorithm to find maximum of array element. In this case, max is the name of the algorithm, A is an array, and N is the size of the array. Initially, let me assume the maximum is stored in the result, and the maximum value is A of 1. The comparison starts from the second element to the nth element, that is for I is equal to 2 to N. Compare the array element with the result. If the array element is greater than the result, then the maximum value will be the corresponding array element. That is, if A of I is greater than result, then the result is equal to A of I. The final answer, the maximum value, is stored in the result that is being returned. In this session, we discussed what is an algorithm, its characteristics, how to devise, validate, analyze, and write the algorithm. Thank you.